Alright, hi everyone, welcome to my YouTube channel, City of Electrons. And in this video we're talking about product of vectors. So the product of vectors, if you multiply two vectors, that's called product. Like the multiplication of two vectors is called product of vectors. But the thing is this, if the result you get is a scalar, then it's a scalar product. That is, if the product of two vectors result in a scalar, it is known as a scalar product. Then, if the product of two vectors results in a vector, it is known as a vector product. Okay? Now, let's talk about scalar products. So, now for the scalar product, it is denoted as this: A dot B. We'll be working with A and B, so let's work with that. So, for this A and B, it's defined as the product of the magnitude of A and B and the cosine of the smaller angles between A and B. That is, for A and B, that's this thing we have here. This thing means scalar product. Okay, this is how we denote a scalar product. Okay, mathematical representation. Then, okay, we can put it that way. Okay, then this thing, this scalar product just means we are going to multiply the magnitude of A and the magnitude of B. Then we are also going to multiply it by the cosine of their smaller angle. That is the angle between A and B. Okay. So now this sign, of course, this sign here, this thing there means the angle between A and B. So just note that the scalar product is often called dot product because of what we have here. This guy, these dots. Okay, so because of that dots, is often called the dot product. So whether we say dot product or scalar product, we are talking about the same thing. Then there are some properties of the scalar product we need to bear in mind. Properties of scalar products. This will help us when we do our calculation. Okay, scalar products. Properties of scalar products. Now, so one of the first thing to note is that A dot B equals 0 if, okay, now the first thing to note is that A dot B equals 0 if this guy equals 90 degrees. Remember, cos 90 is what? Okay, cos 90 is 0. So if cos 90 is 0, then whatever we have here will equal 0. That's just it. Okay, because cos 90 equals 0, 90 cos 90 equals 0, 0 multiplied by whatever you have here, it will all make AB equals 0, A dot B equals 0. So that's why one of the property is that A dot B equals 0 if the small angle between them equals 90. When I say equals 90, which means they are perpendicular or at right angle to each other. So A dot B, if A dot B is perpendicular, then the scalar product is 0. Okay, then the second property we are going to talk about is for if this guy here, if this is 0, if that is 0, then what's going to happen? A and B are parallel. Okay, A and B are parallel. So let me bring it all together. Okay, bring that here. So if the angle between them is 0 degrees, then A and B are parallel. A and B, okay, A and B are parallel, yeah, A and B parallel, okay, parallel. Okay, now think of it this way. So this is A, this is for A, and this is for B. A, vector B. Now they are, in this case, they are at 90 degrees. So the angle between them is 90 degrees. So in this case, of course, A dot B will be 0. They are not even in the same direction. Now, if the angle between them is 0, that means A and B are heading in the same, like there's no angle between them. Theta is 0, no angle between them, which means they are parallel to each other. Okay, just like saying this angle, now we reduce it to this, we reduce the angle until we reduce it to the point where the angle is 0. That means A and B, they are parallel. That's the meaning of the second property. Okay, A and B are parallel if the angle between them is 0. Okay, then the third thing to note is that the product can be viewed as the product of the magnitude of vector A and the magnitude of the projection of vector B on A, and vice versa. Okay, so what that means is this. So if we have this vector A, so A dot B can be viewed as A B cos this AB. Then vice versa will mean we can also have B outside and then the projection A cos AB. Space. Undo. Okay. Close this. So we can mean this or this. So the magnitude of vector A and the magnitude of the projection of vector B on A, or we have magnitude of vector B and then magnitude of vector A, magnitude of the projection of vector A on B. So we can have it either way, same thing. So that's for the third property. Then for the fourth property is that the scalar product or dot product is commutative and distributive. So what we mean is this: A dot B can be written as B dot A. So this is commutative. Okay, commutative. Funny writing. So this is commutative. So this is commutative, okay? Commutative. Then for associative, A dot, then when I have B plus C, it's the same thing as saying B plus A dot C. Okay, so this is for, I'm sorry, distributive, I mean distributive. This is for distributive. Okay, so that's that. Then the scalar product can be written explicitly using two vectors A and B, just like the the previous video where the scalar product can also be written explicitly like this. So we have vector A and then we have vector B, but instead of having plus in between, now we are going to have a dot in between. So the scalar product can be written as that also. Okay, so let's take this part, let's copy this part out from our vector addition. We'll need it. A dot B. Of course, you can have this thing, you can have it this side at this other side, not the other way. It doesn't. Okay, let me even bring it this way. Okay, so copy and we have it here. Good. Now A dot B, so let's do our multiplication and see. A dot B, so this will multiply everything here. Like this first term will multiply the first term, that will give us an answer here. This same first term will multiply the second term, that will give us an answer here. This same first term will multiply the third term, that will give us another answer. So we have 3 answers here. Then the second term will do the same thing, multiply first, multiply second, multiply third. We have another 3 answers, 6 terms. Then the third term here will multiply first term, second term, and third term. So I have that. But recall, there is a property. Let me put this first here, or should I say rule or pattern? That is x. Recall that x dot x direction equals 1, even y and y, that's direction, equals 1, and z also, or z, whichever one you call it, equals 1. But if we have x dot any other thing, okay, oh boy, x dot any other thing, okay, that will be 0. Even x dot z, that will be 0. And even let's say y dot z, that will be 0. Okay, so whichever way we have 0 there, or even if we say y dot x, the same thing, still 0. And we say z dot y, that's 0, and another 0 here because z dot x 0. So the point is, as long as they are not the same, that dot product will give 0. But if they are the same, that dot product will give 1. So that means our results here, A dot B, look at this. So look up here. Now this first term, what do we have here? This is x and this x. Okay, so they are in the same direction. So when they dot each other, this will give us 1. So it will be 1. It will give us 1 here, just like what we stated here, to give us 1, multiplied by ax. So we have ax bx. But of course, one multiply anything is that same thing, so we can just cancel out that 1, and we just have ax bx. Similarly, let me bring this back a bit. Similarly, the next term will be plus, because we have a plus sign here. The next term will be ax multiplied by this next term here, which is by. But note that this and this, they are in different direction. So that will give us a what? This and this dot this. That will give us a what? Look at it here. To give us a 0. And that 0 multiplied by ax by, it it will be 0. Okay, so this term will be out. This term will be out. So okay, let me just put this first step so it will be clear enough. So x multiplied as the second term, that will give us 0 multiplied by ax and the second term, which is by. But of course, this 0 multiply this, that will end up as 0. So this is going to be out of the equation. Okay, so wipe that out. Alright, I think I should have used different colors for the different terms, but it's okay. Now ax going to the third term. Now look at it, this z and x, they are not the same. Look at it here, z and x equals 0, or if you want to say x and z equals 0. So therefore, just like what happened to this term here, when they multiply we'll have 0. So ax multiplied by bz or bz, that will be multiplied by this direction and this direction, I give us 0. So 0 will multiply it and we'll have 0 as the answer. So nothing will be there. Okay, so we'll go to the second term here and then we'll do the same thing. So when this multiplies this first term, because this x is different from this y, this is going to be 0, so we are going to ignore that term. Go to the second term here, by. Now we have y here and y here, so we can have a term there. Of course, this y dot y will be 1, so what will be left is ay by. So we now have here ay by. I think you get the pattern already. So this coming to dot the next term, y and z different directions, so that will be 0. So we go to the third term here, this dot this, of course that will be 0, dot this, that will be 0, dot this, that will be 1. So we are going to have az bz. So az bz. So this is something we have for the dot product. Okay, so this like giving it an explicit like writing it explicit. So with this we can see we've written explicitly the dot product, to write the dot product explicitly. Okay. Whew. So we can either use this formula or we use this formula when looking for the dot product. The magnitude of A multiplied by the magnitude of B multiplied by the cosine of the angles between them. So any of this formula will work. Good. Now saying A dot A. Okay, this means that we'll now have the magnitude of A dot the magnitude of A cosine of A. Oh, why am I still writing B? A. But the thing is this, since A and A, they are in the same direction, that means they are parallel. So cosine will be 0. I mean the angle between them is 0. Okay, so that means A dot A equals A magnitude of A. This will be squared now because A that will be squared. Okay, and then the cosine, which is cos, which will be cos what? 0. And of course cos 0 is 1. Cos 0 is 1. So this will give us A dot A equals squared of their magnitude. Squared. Okay. And then we can see we can say this is a equals a squared x plus, just like from that first formula there, a squared y plus a squared z. So whichever one. Okay. All right, now in our next video we are going to work on an example on this. Okay, so thanks a lot for watching, and subscribe, share, like, comment, and I'll see you in the next video. Thanks for watching, and bye for now.